Hello, my name is Max Levine and I'm entering my third year as a computer science major at the University of North Carolina at Asheville.
And my name is Alicia Tapiawala and I'm entering my fourth year as a computer science student at the University of Texas at Dallas. We decided to base our research on a comparison of quality assurance in safety critical software versus non-safety critical software. So during the lecture portion of this program, we learned about the multitude of arduous QA methodologies used for safety critical software. These industry-wide standards are in place due to the inherent nature of safety critical software. When failure is not an option, testing in QA becomes very important. The same, however, cannot be said of non-safety critical software. However, if we can apply one of these safety critical QA methodologies to non-safety critical software, perhaps we can produce non-safety critical software that is more thoroughly tested before release and produce a better trend in software development overall. So our research had a bit of a rocky start. Our initial plan was to simply survey both safety critical developers and non-safety critical developers on their projects that they've had in the past. For the non-safety side, we decided to narrow this down to video games because not only are they especially non-safety critical, but we assumed that we would get more interaction from this type of crowd. And we were right, we had plenty of responses from video game developers. However, on the safety critical end, we received no responses. And this was either due to the development of these projects not being available to the public, or simply because we cannot get in touch with the right person. And on the developer end, it appeared that these game developers didn't have much of an idea about QA, so this lack of responses required us to make a new plan. So our new plan was to create a translation of an already in-use safety critical QA methodology such that it's applicable to most non-safety critical software. In addition to this, we wanted to make a game which can inform developers and programmers on these currently used safety critical methodologies.
So we had multiple objectives in creating this game. One was to see if the gamification would be effective at teaching these developers because we found that many of these indie yet skilled developers didn't practice QA. These developers may move on in their career to safety critical and programming games with proper QA can be a safe learning environment and form good habits. Another use for the game was as a place for us to store our knowledge that we researched. We have sections in the game that teach about where we shut off the information that we got from interviewing these game developers. And there's a section that's playing right now about different QA standards and methodologies. Later sections on malicious logic faults, and there are a few subjective questions that ask about how, possible software failures. And the game ends telling you how much of the info you've looked at, just to encourage people to explore and learn more.
So let's move on to the translation portion of this project. So why does there even need to be a translation at all? Believe it or not, there's actually a few key differences between safety critical development and non-safety critical development. One of those first things being testing in QA for safety critical development is usually done before release. Testing in QA is done for non-safety critical software before release as well. However, they also employ methods such as beta testing in order to assess the quality of their products. Furthermore, testing in QA is done throughout the entire process of the development of a safety critical system. Non-safety critical projects, on the other hand, save testing in QA for the end of the software development lifecycle. Lastly, safety critical development takes consideration of the entire system. For example, when creating aviation software, you have to take into consideration the hardware that was produced specifically for this software. Non-safety critical software, on the other hand, majority of them operate on hardware that has already been introduced and implemented. That being said, there isn't much of a concern when it comes to non-safety critical software about the synthesis between software and hardware. So the safety critical QA methodology that we chose was FMEA, or Failure Mode Effects Analysis, and we chose this due to its use of metrics and mathematical equations. So let me briefly go over FMEA, and there's different ways to apply FMEA, and this is just one of them. So step one is to determine the potential failures of the safety critical system. Step two is to assign a severity, occurrence, and detection level on a scale of 1 to 10 to each potential failure. Lastly, an RPN, or risk priority number, is calculated for each potential failure, and each of these failures are put on a list that is ranked in terms of their priority. So let's talk about the translation. So we're going to keep the methodology the same for the most part. However, instead of considering potential failures, we are going to be considering business risks. And business risks are simply failures in the software that can lead to some net loss in the company. We will also still be assigning severity, occurrence, and detection levels to each of the risks, and we'll be calculating an RPN for all of those as well. However, now we are going to be assorting the FMEA into different categories in order to inspire more thinking and more business risks. For example, if you wanted to apply FMEA to banking software, you might have categories such as transfers, deposits, and withdrawals, and you would have a separate FMEA analysis for all three of those categories.
So we released the game for beta testing, and we received bug reports that for each bug we looked at according to the aforementioned FMEA. And for example, there was one bug that caused the game to run very slowly on many computers, and that would have been classified as having a higher RPN. In addition to bug reports, we also got back some other information, including how effective the game was at teaching and whether the gamification is a viable method. So part of our survey involved comprehension questions. On the first one we released, 80% of the people got it right, and on the second iteration, the majority got 86% of the questions right. So that was an increase of 6%, so not statistically significant, but there was a lot more content in the second iteration. So slightly more percent of people believed after the second iteration that the game was well presented as a game instead of just a static text document. We also found that people went out of their way to answer questions, which is a sign that the gamification was working, and also the majority felt that they learned something new.
So let's move on to the translation portion of this project and the observations that we made during that time. So the first is that a lot of QA methodology uses a prevention and recovery based approach. And this proved to make the translation a bit more difficult because it's difficult to recover from a business risk via software. Furthermore, hazards and risks are the backbone of most safety-critical QA methodologies. And using business risks as a placement for that also proves to be difficult because while we know what things have to happen in order to damage life, property, or the environment, it's difficult to determine exactly what would net a loss for a company. And this also creates a lack of a ceiling for business risks, as the list of business risks produced from FMEA could potentially be endless. So this makes a lack of a ceiling and creates an open-ended QA method. So in conclusion, the differences between safety-critical development and non-safety-critical development are vast and varied, and this makes it difficult to apply the QA methodologies of one onto the other. However, if non-safety critical development incorporates some aspects of safety critical development, such as the use of metrics to prioritize different risks, perhaps this could lead to a better trend in software development overall.
So far, findings on whether the gamification can teach this information is inconclusive, but with future work, I think we could prove otherwise. But we do know is that it was helpful to teach us as a place to store and organize the information.
Thank you so much.
Yes.